This video will look at some additional problems that involve point-slope form that will help to supplement the questions that you would find in your reference guide. Now, when we look at the first problem, this is a common style of question when dealing in point-slope form. We're asked to take an equation and to plot it on the axis that's provided. And in order to do that, we need to remember what everything is in point-slope form. So our equation for point-slope form, y minus y1 equals mx minus x1, we can see how that is translated on the equation that's provided. And if we start at our negative 3/4, we can see that that is right after the equal sign, and it's in the place of m. So that means that our slope for this equation is going to be down 3 and to the right 4, or negative 3 over 4. And then we look at our other two values. We have a plus 1, and we have a negative 4. And again, if we remember what that means, if we think back to reference guide 4, we know that those are the coordinates of a known point on our line. But there's a catch. We remember that when taking the coordinates of the known point, we have to switch our signs. So what we read as y plus 1, that means that the known point will have a y value of negative 1. We switch that sign. If it's positive in the equation, it's negative when we're taking its coordinate. And then if we look at x, it's negative 4. Well, that means that the x coordinate will be positive 4. So our known point lies at 4, negative 1. Again, remembering back to reference guide 4, the reason we switch our sign is because of the negative signs that we see in our equation for point-slope form. We have to account for those. And the way we account for the negatives that I just circled is by changing the sign. So now we're ready to plot our line. We have a point, we have a slope. So we're going to go to 4, negative 1, and we're going to put our first point. Now we're going to use our slope to come up with two more. And the first point will be down 3 and to the right 4. So that's going to end up right there. Our second point, well, we can't go down 3 and to the right 4 from the point we just made. So we go back to our original, and instead of going down 3 to the right 4, we go up 3 and to the left 4. And that puts our other known point at 2 on the y-axis, which is our y-intercept. Once we're happy with our plotted points, we take our ruler, we line it up so that it's going to go through all 3 points nicely. We extend our line, as we've always done while graphing, and we remember to put arrowheads on the end. And just like that, we've plotted a line for y plus 1 equals negative 3/4 x minus 4. That's all there is to it. You identify your slope, you identify the coordinates of the point that's given, remembering to switch your signs when you do so, and then you get your 3 points, connect them with your ruler, and you're done. Question number 2 is asking us to do essentially the reverse. So in the first one, we took an equation and we made a graph. On this question, we're taking a graph and we're creating an equation from it. So we'll notice that there's 2 plotted points. And we're asked to make 2 equations. So we'll use each of these points when coming up with our 2 equations. But the first thing we're going to need is a slope. Well, this point is found at 1, 1. This point is found at 4, negative 1. So we can come up with our slope quite easily once we have our coordinates by using the formula that we continue to use, which is m equals y2 minus y1 over x2 minus x1. So our slope is going to be negative 1 subtract 1 over 4 subtract 1, which, when simplified, is negative 2 over 3. So we have our slope. That's going to help us to come up with both of our equations. And now, since we need 2 equations, we're going to do one for each of the points that's given. So our first equation, again, we're using the form y minus y1 equals mx minus x1. And we're just going to plug in our values. Well, for the top point, 1, 1, our y1 value is 1. The y-coordinate of that point is 1. So where I see a y1, I'm going to plug in the number 1. Our slope is negative 2/3. And our x-coordinate of that point is also 1. So we don't have to simplify that at all. That's all done for us. So our first equation is y minus 1 equals negative 2/3 x minus 1. Our second equation is going to come from the other point. Again, using y minus y1 equals mx minus x1, we can plug in our values, and for this one we will have to simplify. So the y-coordinate of that point is negative 1. Our slope is still negative 2/3. That hasn't changed. Our x-coordinate is 4. So we have y subtract negative 1 equals negative 2/3 x subtract 4. Well, we can simplify what's to the left of the equal sign. So we're going to make that y plus 1 equals negative 2/3 x minus 4. And there we have our two equations. It's just that easy. You take the points that are given, and in this case, there's more than 2 points on the line. There's more than 2 places where it crosses perfectly through the grid. But 2 of those were enlarged and kind of highlighted for us, so those are the 2 points we chose. And you create an equation using each of those points to get the 2 equations that the question's asking for. Now, those are some pretty standard styles of questions. We saw those on the reference guides. Take an equation, make a graph, take a graph, make an equation. But there's obviously other things that you can do. And one of those other things that is quite common that you'll be asked to do is to find your intercepts, your horizontal and vertical intercepts. We've looked at this before, but when finding your x-intercept, your horizontal intercept, you set y equal to 0. So when we're finding it for the equation y minus 1 equals negative 2/3 x minus 4, first thing we're going to do is where we see a y, we're going to sub in 0. And now it looks like this, where we can simplify our left-hand side. And we'll get negative 1 on the left-hand side equals negative 2/3 x subtract 4. And now one of the things that we had looked at in previous units is what to do if you have a fraction that's out front. And what we decided, or what we figured out, is that you can set all your numerators as side by side so that you only have, so that it's all over your denominator. So instead of writing negative 2/3 multiplied by x minus 4, we can write negative 2 multiplied by x minus 4 all over 3. And where that becomes useful will be in 1 second when we want to get rid of this denominator 3. So I've simplified my top. I use the distributive property to do so. But now I want to get rid of this 3. I don't like having a 3 there in the denominator place. So let's get rid of it. Let's multiply both sides by 3. That will cancel it out on the right-hand side. And it will leave us with negative 3 equals negative 2x plus 8. I'll go up here. And now we just have to solve this expression. Well, to do that, we're going to move our plus 8 over, our positive 8 over, by subtracting 8 from both sides, which will give us negative 11 equals negative 2x. Divide out the negative 2, and we have an x-intercept, or a horizontal intercept, of 11 over 2. Okay, that trick of putting everything over top of your denominator 3, it's something we looked at in the measurement unit, and it comes in handy here because then you don't have to work with fractions for any longer than you have to. So that's the x-intercept, and now, since I'm going to be short for room, I'll block that off with green, and we'll look at the y-intercept. Well, if the x-intercept occurs when y equals 0, the y-intercept, of course, occurs when x equals 0. So I'll go back to my equation, and where I see an x, I'm going to plug in a 0. This will give us y minus 1 equals negative 2/3 multiplied by negative 4. Well, we can simplify that. Y minus 1 equals 8 over 3. So now we have to work with this expression, y minus 1, or this equation, y minus 1 equals 8 over 3. Well, I'm going to have to move my minus 1 over by adding minus 1. So let's do that, and then we'll see how we're going to handle it. And we know that in order to add fractions, you need a common denominator. So we can't take 8/3 and add 1 to it, but we can change 1 to 3 over 3. That allows us to add our fractions, and it gives us a y-intercept of 11 over 3. Okay? You could choose to multiply both sides by 3 when you get to y minus 1 equals 8 over 3, and then work your way through that without fractions. But I just chose to move my 1 over, and then I know that in order to add fractions, I need a common denominator. So I changed my plus 1 to 3 over 3 so that I could add it to 8 over 3, which in turn gave me 11 over 3. Okay? And that's how you find your intercepts. Again, we've done this before, not really with point-slope form, but we've done it with other things. And when finding your intercepts, you just remember that if you're finding your x-intercept, you set y equal to 0. If you're finding your y-intercept, you set x equal to 0. Question number 4 is a further extension of point-slope form. This is actually a question that comes off of the SAT review. So for anybody who's thinking of taking the SATs, this is a question that you could be asked on that assessment. So there's 2 ways to do this. We may do it both ways, but it asks us in the question to use point-slope form. So we'll start there. So the points 3, 9 and x, 8 lie on the same line. If its slope is 1/2, use point-slope form to determine the value of x. So let's see how we would do this using point-slope form. Well, we know m is 1/2, and we know that our given point is 3, 9. So we're going to use this information There we go. We're going to use this information to come up with our value of x. So we're going to put it in our equation y minus y1 equals mx minus x1. And we're just going to sub in what we know. Well, we know our y value, or our y1 value, is 9. We know our slope is 1/2. We know our x1 value is 3. Those come from the known point. And now we have this other point on the line where there's an x value that's unknown at this time, but there is a known y value, and that known y value is 8. So where we see y in our equation that's in point-slope form, we can plug in the 8. So that will leave us with 8 subtract 9 on the left-hand side, and 1/2 multiplied by x minus 3 on the right. Well, let's simplify both sides. So negative 1 there, and then x minus 3 over 2 on the right-hand side. So again, we did that trick where we just moved everything and put it under the denominator 2, or put it over the denominator 2. So in order to do this now, I don't want that denominator 2. I don't want to work with fractions if I don't have to. So I'm going to multiply both sides by 2. So 2 multiplied by negative 1 equals x minus 3 over 2 multiplied by 2. That will cancel it out on the right-hand side. It will give me negative 2 equals x minus 3 on the right-hand side. So now, all we're going to have to do is solve for x. This is a pretty easy one. So we're going to add 3 to both sides so that x gets left on its own. This will give us x is equal to 1. Okay? So we can use point-slope form to figure that out. Now, it asks us in the question to use point-slope form, But there is another way we could do this question, where if it didn't ask you to use point-slope form, you could solve it maybe even a little bit easier. So we could use our formula for slope to do that. So we know slope is m equals y2 minus y1 over x2 minus x1. Well, we know that our m value is 1/2. Our slope is 1/2. Then we would have 9 subtract 8 over 3 subtract x. This will leave us with 1/2 equals 1 over 3 subtract x. So we know that our left-hand side and our right-hand side have to be the same, which means that 2 has to equal 3 subtract x. So we can get x by itself by subtracting 3 from both sides, which leaves us with -1 equals -x, or positive x equals +1. Again, both of those ways are valid. Since the question asks us to use point-slope form, that's what's done in blue. That's the way that you would be solving it. But if it didn't say to use point-slope form, then you could have just used your formula for slope. Okay? And those 4 questions are further extensions of point-slope form. There are others, but that gives you some insight into some other ways that this can be used.